Look up. Above us lies a canvas of ever-changing forms, clouds. They captivate us with their beauty, shield us from the sun, and even warn us of coming storms. But what exactly are clouds, and how do they form? Join me now as we embark on a journey to unravel the secrets of these celestial wanderers. Clouds. Those ethereal wisps that drift effortlessly across the sky. They might appear as fluffy cotton balls from a distance, but in reality they are far more intricate and fascinating. Clouds are composed of countless tiny water droplets or ice crystals, so small and light that they remain suspended in the atmosphere. Imagine for a moment a single raindrop. Now, divide that raindrop into millions, even billions of minuscule particles. These particles, so small they are invisible to the naked eye, are the building blocks of clouds. The formation of these celestial wonders begins with the sun's warmth. As the sun heats the Earth's surface, water from oceans, lakes and rivers evaporates, transforming into invisible water vapor. This warm, moist air, lighter than the surrounding air, begins to rise, much like a hot air balloon. Gazing up at the sky, one is struck by the sheer variety of cloud formations, each one telling a different story in the sky. Each cloud has its own unique characteristics and beauty, painting a dynamic picture above us. Over the centuries, meteorologists have categorized these celestial wonders into a system that helps us understand their formation and behavior. This classification has been crucial for weather prediction and understanding atmospheric processes. Let's begin with the cumulus clouds, those fluffy white masses often resembling cotton balls scattered across a bright blue sky. They are perhaps the most recognizable and beloved of all cloud types. Cumulus clouds are a sign of fair weather, formed by rising thermals of warm air. These clouds can grow and evolve, sometimes leading to the development of larger storm clouds. They are, in essence, the visible manifestation of rising air currents, a dance of warm air meeting cooler layers. Next we have the stratus clouds, their name derived from the Latin word for layer. These clouds are often associated with gloomy, overcast days. These clouds typically appear as a flat, grey sheet, blanketing the sky and often bringing overcast conditions. They can stretch for miles, creating a uniform, dull sky. High above the Earth's surface, we find the delicate wisps of cirrus clouds. These clouds are often the first sign of an approaching weather front. Composed entirely of ice crystals, these clouds appear as thin, feathery streaks, often signaling fair weather or an approaching change in weather patterns. Their delicate appearance belies the cold temperatures at which they form. Cirrus clouds form at high altitudes, where temperatures are consistently below freezing. They are a testament to the extreme conditions found high in the atmosphere. And then there are the nimbus clouds, harbingers of precipitation. These dark, dense clouds are often seen during storms, bringing rain, snow, or other forms of precipitation. Have you ever gazed up at a cloud-filled sky and wondered, why don't they fall down? How do they manage to stay up there, seemingly defying the laws of gravity? It's a question that has intrigued observers for centuries, from ancient philosophers to modern scientists. And the answer lies in a delicate balance of forces, a dance between gravity and buoyancy. We know that everything on Earth is subject to gravity, that invisible force pulling objects towards the center of the planet, making sure nothing escapes its grasp. So why do clouds, often weighing tons, defy gravity and remain suspended in the air almost effortlessly? The secret lies in the size and weight of the individual water droplets or ice crystals that make up a cloud. These particles are so incredibly small that their rate of fall is incredibly slow, almost imperceptible. Imagine for a moment a feather falling through the air. The feather's large surface area and light weight cause it to descend slowly, caught by even the slightest breeze, drifting gently. The same principle applies to cloud droplets, their minuscule size and weight allowing them to remain aloft, creating the beautiful clouds we see. Chapter 4. A spectrum of light and shadow. Clouds, those celestial chameleons, transform their appearance as effortlessly as a chameleon changes its skin. One moment they gleam with a brilliant white, reflecting the sun's rays like celestial mirrors. The next they darken to a foreboding grey, casting ominous shadows across the land. What is the science behind this dramatic transformation? The answer lies in the way clouds interact with sunlight. When sunlight encounters a cloud, it is scattered in all directions by the countless tiny water droplets or ice crystals within. This scattering of light is known as mere scattering, and it is what gives clouds their white appearance. However, as clouds grow thicker and denser, the sunlight struggles to penetrate the layers of water droplets or ice crystals. Chapter 5. Orchestrating the Heavens. For centuries, humans have looked to the heavens, marveling at the power and unpredictability of weather. The sky has always been a source of wonder and mystery, inspiring countless myths and legends. We have sought to understand the forces that drive rain, wind and storms, and to harness these forces for our own benefit. From ancient rain dances to modern meteorology, our quest to control the weather has been relentless. In recent decades, we have begun to unlock some of the secrets of weather modification, and one of the most intriguing areas of research is cloud seeding. This scientific endeavour holds the promise of transforming arid regions and mitigating droughts. Cloud seeding is a weather modification technique that aims to increase precipitation by introducing artificial particles into clouds. These particles serve as catalysts for rain formation. The process involves dispersing tiny particles such as silver iodide or dry ice into the atmosphere. These substances are chosen for their ability to encourage water vapour to condense. These particles act as condensation nuclei, providing a surface for water vapour to condense around. This is a crucial step in the formation of raindrops. The idea is to enhance the natural process of cloud formation and precipitation. By doing so, we can potentially influence weather patterns in a controlled manner. By introducing additional condensation nuclei, cloud seeding aims to increase the number of raindrops that form within a cloud, potentially leading to increased rainfall. This technique could be a game changer for agriculture and water management in drought-prone areas. Chapter 6. Reading the Celestial Tapestry. For millennia, humans have looked to the skies, seeking to decipher the language of clouds, to unravel the mysteries they hold about the weather to come. And indeed, clouds, those celestial storytellers, offer a wealth of information to those who know how to read their silent language. Puffy cumulus clouds, resembling cotton balls adrift on a summer breeze, are generally harbingers of fair weather. Their presence signals rising air currents and stable atmospheric conditions, a welcome sight for picnickers and sunbathers alike. Stratus clouds, on the other hand, with their flat, featureless appearance, often portend overcast conditions. These clouds form in stable air masses where there is little vertical movement, resulting in a blanket of grey that can linger for hours or even days. High-altitude cirrus clouds, those delicate wisps of white, are often seen as harbingers of change. Chapter 7. Architects of the water cycle. Clouds, those celestial wanderers, play a far more crucial role in our planet's delicate balance than their ephemeral nature might suggest. They are, in essence, the architects of Earth's water cycle, the intricate system that circulates water between the atmosphere, oceans, land, and living organisms. The journey begins with evaporation, as the sun's warmth transforms water from oceans, lakes, and rivers into invisible water vapour. This water vapour, lighter than the surrounding air, rises into the atmosphere where it cools and condenses into tiny water droplets or ice crystals, forming clouds. Clouds act as celestial reservoirs, storing vast quantities of water vapour. As these clouds move across the globe, driven by wind currents, they transport this precious moisture from one region to another. Chapter 8. Curious Clouds and Celestial Wonders. The world of clouds is replete with curiosities and wonders, from rare formations that resemble UFOs to clouds that generate their own lightning. Let's delve into some of these fascinating phenomena that continue to captivate skywatchers and scientists alike. Lenticular clouds, for example, are often mistaken for UFOs due to their smooth, lens-shaped appearance. These clouds form in the lee of mountains, as air is forced to rise and cool over the mountain peaks, creating a series of standing waves. Mammatus clouds, with their surreal bubble-like formations, are another striking example of nature's artistry. These clouds typically form on the underside of thunderstorms, as cold, sinking air creates pouches of cloud that resemble giant cotton balls. Noctilucent clouds, also known as night-shining clouds, are the highest clouds in Earth's atmosphere. Nature's masterpieces. From their delicate beauty to their profound impact on life, weather and even human innovation, clouds are more than just a skyward spectacle. They're nature's masterpieces. Next time you look up, take a moment to appreciate the science, magic and potential of clouds.